dealing with radicals and exponents. Radicals and exponents. And you'll find out very quickly that radicals and exponents are the same thing. Radicals are exponents. They're just rational exponents. So we're going to hopefully finish today by being able to evaluate radicals with varying indexes and evaluating powers that aren't integers. They're going to be fractional exponents. And some of you have experience with this, some of you don't. So it just depends on who you are. When you see a radical like this, the nth root of a, n is in this little v, you need to make sure that you get it inside the v if it's an index. So the number that goes inside this little v here is an index, and then this is the radical symbol. So we have the nth root of a. That's how you read this, the nth root of a, and it's equal to b. If you wrote it exponentially, it would be b to the n power is equal to a. You would raise both sides to the nth power, and you get b to the n is equal to a. I don't know what your experience is, but I don't think too many of you have a lot of experience with an index other than a 2 or a 3. You're going to see that you'll have indexes of other numbers in this chapter. Another recommendation for you would be try not to use a calculator. Literally as much as possible. When you're going through this chapter, if you feel like you need to reach for a calculator, ask yourself if you really should be, because it's a really complicated calculation, or if it's something you really should know. And if it's something you should know, you've got to work on not using the calculator. On the left-hand side, right here, a to the m over n power, that's called, bless you, exponential form on the left here. If you have a rational exponent like m over n, and you want to turn it into a radical form, the n, the denominator, becomes your index. In the m, the numerator of your rational exponent can either be put on the base to a power under the radical, or you could just take the nth root of the base, a, and figure out what that is, and then raise it to the m power. All three of those expressions are equivalent. And I put the red arrow here to let you know that if you have radical form, you can turn it into exponential form. It goes in both directions. Both of these are radical form. And then on the left, you have exponential form. But you're going to see exponents that are radicals, or that are fractions in this chapter. And that's not something you probably have a lot of experience with. In the second half of this course, you're going to see a lot more material where you say, this is all new. Or I've seen some of this, but not all of this. Okay? So where you put the power m, the numerator of this fraction, is up to you. If a is a perfect root, then you want to put the m on the outside. If a is not a perfect root, an nth root, then you put it on the inside. Doesn't matter. Any questions on this? Okay, so in this example, what's the 3 called? That's the index. What is the 8 called? It's not the root. It is in the base position when we raise it to a power, but this isn't really being raised to the power. The thing under the radical is called the radicand. I thought that was something that we talked about before. And the 2, when we come over here, becomes the base in this problem. The 2 raised to the power of 3 is equal to the radicand. So when we get it into exponential form, this becomes your base over there in exponential form. 3 is the index, and 8 is the radicand. I think we've talked a little bit about this before, and we certainly are going to talk about it now. My recommendation is that you know the first 15 perfect squares, 1 through 225 perfect squares. And I really think you should know your perfect cubes, 1 through 5. If you know the first 5 perfect cubes, these ones right here, and these right here, you're in pretty good shape. You need to memorize them. It's not that you don't know them or that you wouldn't necessarily be able to come up with 5 squared is 25, 10 squared is 100, 15 squared is 225. It's not that you can't generate the table. It's easy. It only takes a few seconds. But students who don't memorize these, you're putting yourself at such a disadvantage for this chapter. I don't even know where to begin. You've got to go through and get these examples. You don't need to know all of these. You certainly don't need to know all of those. But you do need to know your powers 1 to 15 squared and 1 to 5 cubed. You should also consider learning the powers of 2, 2 to the first, all the way up to 2 to the 10th. Okay? They're really easy to learn. You know most of them anyway. But you want to know 2 to the first, all the way to 2 to the 10th. And knowing 3 to the first, all the way up to 3 to the 5th will also help you. So that's something to add to the list, and it will come up later. Powers of 2, 2 to the nth, n equals 1 through 10, and powers of 3. So 3 to the n equals 1 to 5. These are things that put you at an advantage. Some of you are going to say, screw it, I'm not going to do it. You will always be behind. You're always going to be trying to raise your grade. You're always going to be struggling to get ahead in this class. Learn these things. Honestly, it's not that hard. 2 to the first is 2. 2 to the second is 4. 2 to the third is 8. 2 to the fourth is 16. 2 to the fifth is 32. Most of you know those. Not just can generate them, but you know those powers. Add to it 2 to the 6th, 2 to the 7th, 2 to the 8th, 2 to the 9th. And the powers of 3, 1 through 5, good to know. Why are they good to know? Because the book, the teachers, the test makers, we don't really want to work with big numbers. It's hard to work with 7 to the 5th power. The numbers get huge. These ones don't. Sorry? This is powers of 2. 2 to the first, 2 to the second. If you know the first 10 powers of 2 are great. The first 5 powers of 3 are great. These are numbers squared, n squared up to 15 squared. And this is the numbers cubed. These and these are different. Okay. Any questions on this? Okay. So now, rational exponents or fractional exponents, how are they related? How does the radicals come into play? This is 4 to the 1 over 3 power. The number on the bottom is going to become what? What did we say that would become in earlier? The what? The index. So the 3 is going to become the index. Okay? The denominator of the fraction. If we're just looking at this. Okay? That 3 is going to become the index. What do you do with these 2 powers based on what we've learned already? You multiply them, and what will that give you? Yeah, not so much. Not even 9. We're multiplying the exponents. It would give you, it will not. 1/3? No. Oh my God. What power is on the 4 right here?
Oh, 4.
What power is 4 being raised to? 1/3. Raised to the second power. What do you do with your exponents? Multiply them. What do we get when you multiply? Holy smokes.
You get 16.
Let's write it down. You don't. You don't. 2/3.
How?
You said something over 6.
Oh,
No, he said
You said
2/3.
2 to the, oh, it sounded like you said 2 to the 3rd.
Oh.
That's what it sounded like.
How do you do
You don't get 2 to the 3rd, you get 2 over 3.
Oh, you would multiply the 2 into 1.
2 times 1, 1 times 3, 2 times 1/3 is 2/3. The 3 becomes the index. The 2 is the floating power. Whether you put it on the inside or the outside will be up to you. This becomes the cube root of 4, and then we square it. Or we could do the cube root of 4 squared. It doesn't make any difference to me which of those two you put. The last one is going to be the best one because that's the one that will allow you to simplify. But that's not important to me right now. We're not talking about simplifying. We're talking about changing from exponential form to radical. See if you can do this one. Again, this is 4 to the 1 over 6 power. So see if you can switch it to either of the radical forms. It doesn't matter which radical form you switch it to, but just see if you can switch it to a radical. What does it become when you get rid of the parentheses here? 5 over 6 power. So what's one way that I could write it as a radical? What's one way that this could be written as a radical?
6 and the little index as an x radical, 4 and then in parentheses and then 5.
On the outside? So the way we read that, when you have an index, you say it's that index to the, so the 6th root of 4, and then you said what? To the 5th? Okay? So the 6th root of 4, all raised to the power of 5. Your other option for that power of 5 is to do what with it? Put it inside, and it will be the 6th root of 4 to the 5th. Now again, on this one, this is going to be the better way to go, but in other cases, this would be the better way to go. But for this problem, both here and here, later on, this is going to be more important. It's not important today, it's just important in the future. And it's not important for you to be able to differentiate today. Any questions on those two? Now, here is something expressed exponentially. We want to switch it from rational exponent form, which is this, into radical form. And we want to look at two ways to handle it. So one of the things, we can take 16 to the 3/2 and work it with rational exponents. What's something else I can do with the 16 besides switch it to radical form? You can't, it's an expression. You can't because it's an expression. You change the value. And I'm just talking about the number 16.
4 squared.
You could rewrite it as 4 squared. If we rewrote the 16 as 4 squared, we can then apply our properties of exponents. What does 4 squared to the 3/2 become? 4 to the 3rd. And what's 4 to the 3rd? Down the page. Not equals equals equals. So we didn't have to switch this to radical form, although, as you're going to see in a minute, you could have. Does everybody follow what we did here? What else could I have done with this 16? What's another way to write 16? Better known as 2 to the 4th. So we could have gone with 2 to the 4th to the 3 halves. When we multiply exponents here, what will that give you? 2 to the 6th, also 64. Again, powers of 2, they happen all the time. If you know your powers of 2, you're going to be in a great place. You can't use a calculator for this. If you are, you're not giving yourself a chance to get better. Don't use a calculator. Nothing we've done so far needs a calculator. Don't use it. So 16 to the 3 halves. Let's switch it to a radical form. What would that look like if I switched 16 to the 3 halves power? What would it look like as a radical? Right?
Second, a little radical. Second, 2 to the 5 square.
Second power of 16 to the third.
One more time?
Second power of 16 to the third.
Yeah, I want to change it to radicals. We already did exponents, right? What is it? 3 root 16. Don't forget your basics. No. Killing me. Nobody, thank you. The square root of 16, you want the third on the outside. Nobody puts a 2 here. We talked about this. Huh? Have you ever put a 2 here? No. No, why? Because everybody in the country knows that this means the square root, right? We don't put a 2 here because why? Because we're lazy. This isn't stuff new. You know square roots. You guys are supposed to know square roots already. What's the square root of 16? 4. Cubed is 4. Now, I'm going to show you the other one, but again, this would be like, why would you ever? You could have done the square root of 16 cubed. Right, because who knows what 16 cubed is? And since you can't use a calculator, something's wrong. You don't want to do 16 cubed. You mean like I did right here? No, it is what I've already done here. I've already showed you that. I'm showing you the other one. And now we're talking about why you would never want to do this. You would want to do this. In this case, what's 16 cubed?
4096.
And again, 4096, most of us don't know that the square root of 4096 is 64 off the top of our head. This is pain and suffering. And in order for you to do it, you're either going to have to cheat or you're going to have to do the pain and suffering. 16 times 16 times 16, and then try to figure out what the square root of that is. Look over here, see if there's an easier way to do it. Negative exponents, what does that tell you to do? What is a negative power?
Put it on the bottom.
Yeah, send it to, put it over 1 or under 1, one of those things.
So 1 over 6.
But first we're going to look at this, and we're going to look at it using exponents. Now, you have 32 to the negative 3 halves, which would be, how can I rewrite the 32? To the 5th. So 2 to the 5th to the negative 3 halves becomes 2 to what power?
Negative 15 over 2.
Negative 15 over 2 power. Not very nice. Not very pretty. Which is going to become 1/2 to the positive 15 over 2 power. All a negative tells you to do is flip. So this is the base. We flip it, you get 1 over 2, and we lose the negative. We don't flip the exponent. I'm sorry?
Maybe something wrong. Yeah, so it's 1 over 30.
It wouldn't be 1 over 30. So you got 30.
Because 15 times 2, you put 50.
This is base to a power. Okay? It doesn't matter what the power is. This power is negative, right? So you could make this 1 over 2 to the 15 over 2 power, but in no way do you ever multiply power in the base. There's no situation where we ever do that. Right? So 1/2 to the 15 over 2 power would become the square root of 1/2, all raised to the 15 if you went radical. I'm just going to stop on this one for right now and leave it like that. Okay? That's using rational exponents. If we use radicals, this is going to become the square root of 32 to the negative 3rd power. Again, putting the negative 3 on the inside with 32 to the negative 3 power would be 1 over 32 cubed. I don't know that you really want to go there. The square root of 32 to the negative 3rd, we're going to be able to simplify that a little later. Okay? The negative power is going to tell you that we're going to ultimately going to do 1 over the square root of 32 to the positive 3 power. And then we're going to have to do some work when we start simplifying the radicals again. We've done some work simplifying radicals, is that correct? Have we done any simplifying of radicals? The square root of 8 is 2 root 2 or not? Just a little bit. Now we're going to start to see other indexes. And that's going to make things a little bit more confusing. So we'll start looking at what does that do for us when we have these weird indexes in terms of how do we simplify. Now, this is asking you to evaluate using a calculator just so you can see numbers. Just so you can see numbers. 9 to the 1/5 power. 9 to the 1/5 power. If you don't have a calculator, you need to get a calculator. Right? It doesn't matter whether it's graphing or scientific right now, but you need to be able to work a scientific calculator for this class. So 9 to the 1/5 power. If you're evaluating that with a calculator, what do you multiply by itself 5 times to get 9? 1.5. 5, 1, 8. So 1/8 means 5, 5, 2. Why do I stop there? We've said it over and over and over and over again. I know.
Top of the 3rd.
3 decimal places. 3 decimal places. So 9 raised to the parenthesis 1 divided by 5 power, enter. Is anyone not able to come up with this? Because I want to fix it right now, because we're going to do a bunch more stuff. You need to make sure you can use your calculator. It does. You have to do 1 divided by 5. You have that. Oh yeah. So 9.
Yes. Right. Yeah.
So you're going to do 9 x or y to the x, open parenthesis, 1 divided by
Mine's a
5.
little period, yeah.
Close parenthesis.
Divided by 5.
Thank you.
Okay.
Is anyone else not getting the 1.552? 9 y to the x button, open parenthesis, 1 divided by 5, close parenthesis, enter. Not good?
One minus the power is distance. 9 to the 150. So it's 1, 1, so like, pretty much, that's right here. Just right here.
1.8. Not, look at these, Elsa, 9. Do you have a little caret button like this? And then open parenthesis. A lot of pressure, that's all. Open parenthesis, 1 divided by 5, close parenthesis. Anybody else? Okay? Try 12 to the 3/8. 12 to the 3/8 power. Is everybody okay with that? Now this one you might have a little bit of difficulty, and again it depends on your calculator. How can I rewrite this? 3 over 4. Remember, index is the denominator of your rational exponent. So once you get it into something to a power, then it's a lot easier, because most of us can't do the 4th root. And even if you can, it's easier to do a fractional exponent. Whether you can or can't is irrelevant. It's faster to do 7 to the 3/4.
3, 0, 4.
Oh, 3, 0? Let's say you got a decimal that looked like this. What would you give me as an answer on a test? That would be wrong. 3.2 would be wrong. So 3.2, I'm going to go 3dp minus 1. 3.200. Now the reason why you have to put those zeros is because if you put 3.2, that means if we're rounding to 3 places, that's an exact answer. If you rounded and happen to get a 0 in the 3rd place, and in this case in the 2nd place, you would have to say 0.200. That lets me know that you rounded to that point. 3.2 and 3.200 do not mean the same thing. Okay? Does that make sense to everybody? These details are what kill in this chapter. Okay? You should not be using a calculator for this. These are the kinds of problems where you're putting yourself at a disadvantage by not knowing this. The cube root of negative 64. The cube root of negative 64 is negative 4. Negative times negative times negative is a negative. When you take the cube root of a negative, you get a negative. The 6th root of 64. 2. And it's positive. You can't do the 6th root of negative 64. the fourth root of 625? 5. The fifth root of 243? 3. Okay? These are things that you need to be able to generate without a calculator. These are easy. If worst comes to worst, tree it. Okay? If you have 625 and you don't know what the fourth root is for sure, you know something will go into 625, like
25.
maybe 25, maybe 5. 5 and 125. What goes into 125? 5 again. And what goes into 25? 5 and 5. When you get 4 of a kind, that's a perfect fourth. 5 is the fourth root of 625.
Isn't negative 5 also? Negative 5 is bigger.
This is an expression, not an equation. If we have this, x to the fourth equals 625, x would equal what? Plus or minus the fourth root of 625, and you're absolutely right, it would be plus or minus 5. This is just an expression. If they want plus or minus, they'll have to put it right here. You see the difference between the two?
Sort of, why on opposite side, it's the same exact thing.
Okay, it's not. This is an equation. This is an expression. Because it's an expression, there's only one answer. Unless I put and said, if I want to say the square root of 4, the answer for that is 2. If I said the opposite of the square root of 4, what would the answer to that be? Negative 2. If I want the plus and minus root of 4, then it would be plus or minus 2. But when you see this, they're asking for what's called the principal root. And because it's an expression, it's 2. If we were talking about an equation, which we will be very shortly, then absolutely we've got to go plus or minus. Expressions, it tells you the sign that they want in front. If there's no sign, it's positive. Okay, and we're going to come back, we're going to look at this stuff. I don't even want to get it muddied in here. Oops. So I'm not even going to leave that stuff up there. Okay, any questions on these? These are you should be able to do without a calculator. And again, without a calculator. So take a minute and see, you should be able to knock these through pretty quickly. Which one is no work? D. D. What's the answer? 1. Anytime you have 1 to any power, fractional, rational, irrational, any power of 1 simplifies to 1. Don't put equals 1. These are expressions. Down the page. 2 ways to handle 4 to the 5 halves. And it doesn't matter to me which way you want. Anyone have a preference? Change 4 to 2 squared. Multiply your exponents gives you 2 to the, better known as 32. The other way is to go radical, square root of 4 to the 5th, 2 to the 5th, 32. Doesn't matter to me. Radicals or rationals for this one? What should you do with B? Yeah. Put your hands up, right?
Yeah. Are you going to ask for like a certain thing to it?
Yeah, I'm going to ask you to simplify.
But we're using radical form or specific?
You need to be able to do both.
Okay.
Because sometimes this isn't going to work. And sometimes this isn't going to work for you. You have to be versatile and you have to be flexible, I guess is the best word. What are we going to do here? Yeah, you could do that.
9 to negative 3. Square root of 9.
Okay, square root of 9 to the negative 1. What's the square root of 9? 3 to the negative 1? 1/3. You also could have done 3 squared to the negative 1/2 and gotten 3 to the negative 1 that way. 81 to the 3/4. Okay, you could do the 4th root of 81 cubed. What's the 4th root of 81? Cubed. Still getting people who tell me 3 cubed is 9, even in my honors class. Index is 4. Power is 3 on the outside. What's the 4th root of 81? 3 to the 3rd. 3 to the 4th is 81, right?
Oh, okay.
Yeah. So then 3 cubed is 27. Hi. When you go like this, see that word right there above you?
Yeah.
Which one am I pointing at?
The one lower.
Yeah.
Which word?
Right up pointing at that.
Huh?
You're fine, okay?
Yeah. You get my point?
Anyways,
Anyway,
on A, why didn't you write 2 as the index?
why didn't I write 2 as the...
Index of
Because it's always square.
Nobody writes 2 as an index ever.
No, it's not 4 over there.
Right here?
On that one, why didn't you write 2?
Nobody writes 2 as an index. Okay? Remember, when you have this, that means index 2. We don't do that, though. Nobody puts a 2 there, really. Okay? I know you're thinking, I'm looking at this, okay, A, B, M, N, bottom goes in the index. You're right, it is a 2, but we don't put a 2 there, we just say square root. That's what you're asking, right? How come I didn't put a 2 right here? I did, it's just invisible. I have special glasses for invisible numbers. Okay, it's in color. I don't need them.
You're invisible.
No, I don't need them, I can see them. We good? Sure. Okay, now we're going to talk about equations. All right, what does the power on the x tell us for this equation? How many solutions there are? Okay, it tells you how many solutions there are. It could be, but not always. How do I solve this? Divide by 4. So if we divide by 4, 128 divided by 4 is 32, and x to the 5th here. How do you solve fumble?
Sorry, both sides.
You what?
Sorry, both
You what?
Fifth
Fifth
root.
root. Fifth root both sides. When you fifth root both sides, you get x here. What do you get on the other side? 2. Why do you think plus or minus?
That's an equation.
It is an equation, but what's your index?
Oh, we know it has to be
Odd or even?
odd.
Odd. So we don't plus or minus odds, only the evens. So this one, x equals 2, and it is the only solution. Right. Yeah. Whoa. Whoa. What are the ones? We did find all 5. For our purposes, we're good. It's just a quintuple. Right? What's that? Pain and suffering. More pain and suffering than you could ever imagine for that. 4th root of, absolutely. That's 4th root both sides. If you do that, what do we get on the left? Careful now. What do you get on the right? fourth root 21.
Or could you write it?
Write it as a radical. Your fourth rooting, write it as a fourth root. Now what? Add 3. Where should I put it? Unless you- So you get 4 or 3 plus or minus the fourth root of 21. And those are double roots. What can we do for you? Nothing? You tried any medicine? Medicine? They have these, there's people out there to help people who are sick. I don't know if you've heard of them. Yeah. Not that kind of sick. Although that might be an issue too for you. Okay, so you don't want to go see the doctor. You don't need a psychiatrist? Because they care about you. Boy, you try to help. You sick people, you're a lousy patient. People trying to show you the love and you get nothing. What do we do here? Yes, thank you. Directions right here. Cube rooted. What does x equal? 4. If it's an odd degree, we don't plus or minus. Only when it's an even degree and you root an even root, that's the only way to get the plus or minus. So this is just x equals 4. What? Try this one. What do you get? You got to do this first. Wait. Yes, princess, what's wrong? I sounded more like a demand. Soft. Really? That's how you interpreted that?
That's what she said.
Huh.
Yeah.
Interesting. Are we good with the 4? Sure? What do you have to do to this one?
Multiply by 2.
Yeah, you've got to get rid of the fractions first. This 1/2, so you're going to times by 2, and x to the 5th equals 1,024. Here's a perfect example of why knowing your powers of 2 really will make your life easier. X to the 5th is equal to 2 to the 10th. Again, memorize them. It's just a number. 2 to the 10th is 1,024.
Ready?
Riley, what's wrong?
Well, how do we know?
I, about 20 minutes ago, said,
No, but how do we know to change it?
because you memorized that 1024 is 2 to the 10th. When you see 1,024, you have memorized it. Yeah, who's not getting what?
I hit that part, but now.
Well, you have a couple of options. You can 5th root, but honestly, you're better off raising to what power? We want to get x right here. If you raise to the 5th power, won't that give you x to the 25th?
Wait to the 1/5 power.
The 1/5 power. Because when you multiply exponents now, what do you get?
1.
X to the 1st.
Fifth root?
You could, but again, it's easier to do powers multiplied. What do we get when we multiply powers? 2. So you have 2 squared. And that's 4.
Yeah.
I read 2, yeah.
Sure?
Yeah, I'm just going 10 plus 5.
Could we just see that 1024 is 2 to the 10th, and then 4 is just double 2, so it's like so this.
You mean not show work? Is that what you're asking me?
No, I'm saying we show the work, but just.
What work are you showing after this?
I showed everything you did, but I knew that it was only x to the 4th.
Okay, so you got x to the 5th is 2 to the 10th. and then you 1/5 root,
How do you
1/5
do the
power?
1/5 root at this rate x equals 4?
You mean from here to here? Yeah, not so much.
Okay.
Show me the steps in between.
Alright.
I'm giving you easy numbers, not because I care about the answer, because I care about the process. If I gave you really ugly numbers, then the ugliness of the numbers becomes the issue. This way you know the numbers. I'm telling you you're going to know the numbers. Show me the work. Okay? Somebody else had a question on this? Okay? Try this one. With this. But I'm trying to warn you, and it's not working. If we go x squared equals 36, x equals 6.
Now, plus or minus.
You've got to have both answers if it's an even root. Okay, you have to put both answers if it's an even root. I don't know, I'm waiting. You want to write it in your hand? Not a girl? You know, there's an app for that. Yeah. So in the app, like if you tell your phone that you have something, will it verbally tell you? Like, can you? Because I would want it to talk to me. If I seriously, well, Siri, that would be good. But I didn't mean a little pun on that. That wasn't my intent. Siri, what? Yeah, what do you think? Anything like that? Why did she do that? But why don't you, can't you train her? I don't either. Siri can talk in a British accent? Alright. It's cooler? What's x cubed equal?
Hey, hey.
Spotted teeth, really? Okay, only one answer when you have an odd power here. Some of you are going to put plus minus on everything because it's bound to work some of the time. Not what I'm looking for, right? Only if this is an even power do you need the plus or minus. All right, when you're solving here, cube root, huh? So you're going to get x minus 2 is equal to the cube root of negative 14. You know what some of you are going to say next? No? No? JK. What do you think some people are going to tell me about the cube root of negative 14 if we're solving? That there's no solution. You can't take the root of a negative. You can if the root is odd. So how do I solve for x? Add 2. No eyes on this. This is an odd root. The odd root of a negative is just a negative number. So it's 2 plus the cube root of negative 14. Now,